Okay, so probability is it's how likely an event is to happen, right? But it's actually the ratio of the favorable outcomes to all possible outcomes. Okay, so you take, like, you know, your probability of winning the lottery. You would take the ratio of favorable outcomes, that's your one set of 6 numbers, right? And that would go over top of all of the possible outcomes. So that would be every combination of 6 numbers humanly possible from the lottery number choices. Okay, sample space is the list of all possible outcomes.
Ratio of what?
Sorry. Favorable outcomes.
Favorable.
Yeah, favorable to all possible. So the sample space is the list of all possible outcomes. So let's take, if you were going to roll one single die, right? So if you had one die, your sample space, you can roll a 1, a 2, a 3, a 4, a 5, or a 6, right? That's your sample space. Okay. If to say something is equally likely, well, okay, like here, I have 6 sides to a die, right? And if I roll the die, if I want to roll a 1, let's say, I would have 1 over 6. Because there's only one 1. If I wanted to roll a 2, I would still have, there's only one 2, right? So it would be 1 over 6. If I roll a 3, there's only one 3, so it would be 1 over 6. Does that make sense? So equally likely is if your ratios are the same. So if I take one die and I just roll it, right? It's equally likely that I could roll any one of those numbers, because each number only shows up one time and there's only 6 sides. So that's equally likely. Unless, of course, you have some weird trick dice, and then that changes everything. But if you have a normal one, any side is equally likely to come up on top. Okay. Probability, because it's a ratio, it's a fraction. And that fraction always falls between 0 and 1. I spelled probability wrong down here. It's probability, okay. If your fraction is higher, and so it's closer to 1, then it's more likely to happen. If your fraction is low, so it's closer to 0, then it's less likely to happen. So let's say you had some weird, I can't even spell today, wow, weird. So you had some weird dice, and your sides are 3, 3, 3, 3, 4, and 2. Okay? So it's just this really weird, like, malfunctioned dice. Your probability to roll a 3 is going to be 1, 2, 3, 4, because there are 4 3s, over 6, because there are still 6 sides. That's close to 1, because 1 would be 6 over 6, right? So your probability of rolling a 3 on this is more likely to happen than, say, rolling a 4 or a 2, because those are only, to roll a 4, well, you'd have 1 4 over 6 sides. So that's only 1/6. So that's less likely to happen. Does that make sense? Okay, if you want to calculate the probability, you take the number of favorable outcomes and you put that over the number of possible outcomes, okay? So if we take that one die, right, that one die again, there are 6 possible outcomes, right? Because there are 6 sides, and you could roll a 1, 2, 3, 4, 5, or 6. Okay? If I want to roll a 1 or a 5, and either one of those numbers is acceptable, this is 2 favorable outcomes. Because I'm looking at 2 numbers, a 1 and a 5. So the probability is equal to 2, that's my 2 favorable outcomes, over my 6 possible outcomes. So I have a 1 in 3 chance of rolling a 2 or a 5. Okay, rolling an even number, that means 2, 4, or 6, right? Okay, I still have my 6 possible outcomes because, you know, the dice still has 6 sides. But here I have rolling an even number. These are 3 favorable outcomes. Right, so I've got 1, 2, 3 that I would like. And so I put that 3 over the 6, so the probability is going to be the 3 favorable over the 6 possible, and then I'm going to reduce that to 1/2. So my probability is 1 out of 2. So complement is like the opposite. So if you want to roll a 2 on the die, the complement is going to be 1, 3, 4, 5, and 6. So the complement is the set of outcomes you don't want. Okay, so if I said like I want, well, we'll go back to that example where I want a 1 or a 5. Then the complement would be 2, 3, 4, and 6, right? Because that's the different numbers minus the 1 and the 5. Okay, and it's also, it would be called not 1 or 5. So like when they say not green, they mean the complement. So they mean every other color that isn't green. Like right down here. Okay, so we have a bowl, and it has 5 red, 7 blue, 6 yellow, and 10 green. First of all, to find the probability, we have to know how many total possible outcomes there are, so we have to add up all the chips. Okay, so the total possibilities, that's 5 and 7 and 6 and 10. Yeah, so that's the total possibilities, that 28 right there. Okay, blue. There were 7 blue, right? So there are 7 blue. So I put that 7 over 28, which is my possibilities. And so the chances of picking out a blue are 1 in 4. Okay. There are 5 red and 6 yellow, right? So that's 11. So I put that 11 over 28, and I can't reduce it, right? 11 and 28 don't reduce, so that's just That's my probability, 11 and 28. Okay, not green. There are 10 green, right?
Good.
So it's 28
18.
minus 10, yeah, so that's 18. So there are 18 that are not green. So I do 18 over 28, and then I can reduce that. I divide them both by 2, I get 9 over 14. So we have possible outcomes, okay? And when you talk about possible outcomes, that's like every possible outcome is sometimes not as easy to figure out. Like if you have a bowl of chips, you just add them all up, okay? Or you can use a tree diagram. And this is like a diagram that you can use to figure out possible outcomes.
Are we ready for packet thing?
Yeah. Okay, so we have, okay, so I'm going to do this problem two ways. But first I'm going to do it with a tree diagram. Then we're going to go to the next page and I'm going to talk about the counting principle, and then we'll come back and do this problem with the counting principle. Okay? So first we're going to do the tree diagram. Okay, so we have baseball caps, and you can get them in blue, yellow, or white. And then you can either get a mascot or the initials. Right, so if you get a blue cap, you can get a mascot on it, or you can get the initials on it. If you get a yellow cap, you can get the mascot or the initials. And if you get a white cap, you could get the mascot or the initials. So if you look at this, there's 6 possible choices. Right, because you can get a blue one with a mascot or with initials. You can get a white, yellow, so you get 6 possible outcomes. Now a tree diagram, if it's something small like this, that's pretty simple. But if you're looking at larger choices, larger options, the tree diagram is not always the best method to use. So hold on one second. The principle says, okay, so you take all of your possibilities, you multiply them together. So we have ice cream shop has 1, 2, or 3 scoops. So we have 3 possibilities on the number of scoops, right? We have 12 flavors. And then you can have a wafer cone, a sugar cone, or a cup. So we have 3 containers, we'll just say. Containers, right? So we have 3 numbers of scoops. You can get 1, 2, or 3, right? There's 12 flavors, and you can get 3 different kinds of containers: a wafer cone, a sugar cone, or a cup. So to find the number of possible choices of ice cream orders, you take 3 times 12 times 3. Okay, this is 36. Actually, I'm just going to do 12 times 9, so there's 72. No. Guys, when I multiply wrong, call me on it, please. 12 times 9 is not 72. It's 108
I'm not getting math with English.
possible
Horrible.
combinations. Okay, so when you're buying ice cream, there's a... So when you have a situation where you can't repeat, okay, for my first digit, I have a choice of all 10, right? So this is the first digit. But then when I choose my second digit, I already used one, right? So now I can only choose from 9. Because they cannot repeat. And then when I do my third digit, I've already used 2 of them. So Now I can only choose from 8. And then when I multiply that together, I have 720 possible combinations. And this is why passwords are relatively hard to hack, right? They're relatively safe unless you use known words.
10 digits, yeah, that's ridiculous. Mine's like 9 though.
Yeah, but, well, no, this is just a 3-digit password. If you have just a 3-digit password, you have 10 possible digits because you got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But if you only have a 3-digit password, there's 720 possible combinations. And that's not including the alphabet. If we throw the alphabet in there, we'd be multiplying 36, 35, and 34. So that's just a 3-digit password. Now, if you have like a 10-digit password or 6-digit password, it's even less likely. I figured out I have one of those digital door locks where you can plug in a code and your door unlocks. There's 5 buttons. And you can have a code that's between 4 and 8 long. I have a 5-digit code. But with my 5-digit code, there's 3,000 possible combinations.
Damn.
So for somebody to just try to guess and break into my house, there's 3,000 combinations they would have to go through
To find the right one.
to find the right one.
I need one of those. I want to put one in my room. My door.
Okay, now, we talked about probability. Odds are a little different, okay? Odds are the ratio that compares successes or what you want to failures. Now, probability compares successes to every possible outcome. Odds is successes to failures. So when you add the top and the bottom up, when you add the successes and you add the failures, you get the total possible outcomes, right? So let's say we have dice, right? 6 possible outcomes. Total, okay. How many numbers are less than 3 on a die? We have 1 and 2, right? So there's 2 successes because there's 1 or a 2 that you could roll, right? So how many failures are there? 4. So this is possible minus successes. That's how you get the failures. So you take the total possible and you subtract the successes from it. And that gives you your failures. So the odds are 2 over 4, which can reduce to 1/2. Okay. So this actually, your odds here being 1 to 2, these are not good odds. Because you're twice as likely to fail. Mean, median, and mode are called measures of central tendency. And what that means is these are like, you guys have seen like the bell curve before. Have you guys seen that? And most people fall in this area, and you got some people over here and some people over here. The measures of central tendency talk about this part right here. Okay, so they talk about like the averages.
We have to draw this
No. Okay, the mean is an actual average. Okay, so to find the mean, you add up all of your numbers, and then divide by the number of numbers.
I haven't done median mode since like 10th grade, so I don't remember.
Okay, well, we're gonna find the mean on this. Okay, so we're adding up the numbers. So we have $3.50, $4, $5, and $4.50. Okay, so we're gonna add all that up. So 8, 12, 17. So that's 17.
What's the mean?
Well, no, this is the total. Now to find the mean, we take that total and then we add it together. 1, 2, 3, 4 numbers, right? So we're going to divide that by 4 because that's how many numbers we added together. And hold on, what is these? Okay, so my mean is 425. So this is like the average, like her average daily profits. Oops. Okay, median is the middle number.
It'll be 2.
In a list that's numerical. So you have to put them in order first. So first I would take these numbers and I'd put them in order. So I'd go 2, 3, 3, because there's 2 3s, right? 5, 6, and 7. Right. 1, 2, 3, 4, 5, 6. Okay, see now, the middle is right here. Now if there was a number right here, I would just pick that number. But if there's not one, okay, so if there's a number here, so but in our case there was not one. So we're going to add up the 2 to either side. So I'm going to take that 3 and that 5, right? Because they're on either side of the middle. So I'm going to do 3 plus 5. That's 8. And then I'm going to divide it by 2. So my median is 4.
Where do you get the 2 from?
This divide by 2? That's just the rule. Basically what you're doing is you're taking the average of these two numbers.
Also, you use like the number of numbers as
Yeah.
divided.
Yeah. So if we had, let's say, I'm going to give a different list. So let's say I have 2, 4, 9, 5, 8. Or wait, that's not in numerical order, so that does not work. Sorry. 2, 4, 5, 8, 9. Okay. 5 is exactly in the middle, right? So that, if this was my list, 5 is my median. But here I didn't have a middle number, so when that happens, add them together, 2 on either side of the middle, and then divide by 2. Okay, the mode is the number that shows up the most often. Okay, now normally the easiest way to do that is to take and put them in numerical order, because then you can see that there'll be a bunch of them sitting right next to each other. And plus, a lot of times you're asked to find mean, median, and mode, and so putting them in order helps you to find the median, and then it also helps you to find the mode. So I'm going to start looking for my lowest number, which is 70. And then I like to cross them out as I go, so I know I used it. Then I have a 71. Make sure I don't have any more of those. Okay, I have a 72.
272.
And I have another 72. No 73s. 75 will be my next one. I have 2, 3, 76, right? And then I have a 77. And then I have, look at this, 3 78s.
Why didn't you see that?
That's the other reason it kind of helps to put them in order. I have 2 79s. $80, 81, 83, and 84. And now that I've crossed them all out, I can just go and look and make sure I got every number, right? Okay, 76 shows up 3 times, and 78 shows up 3 times. They're both the mode. So my modes, if only 76 had shown up 3 times, it would be 76. But you can have more than one mode. Okay. Yoko got these test scores on her test, and she wants to get an average of 90, so she wants an A. So we need to figure out what does she need to get on her next test. That's an average, right? Average of 90. So these are the tests that she's already taken, and we're going to take a 6th test. We don't know what that is, so we're going to put an X in there. And we divide it by 6, and that would give us the average of 90. Okay, so I'm going to add all of these up. So I have 82 plus 96 plus 92 plus 83 plus 91. So that's 444. Okay. Now I have to get rid of this 6. So I'm going to multiply both sides of the equation by 6. Okay. And the reason I did that is because those cancel now. Okay, so if I subtract 444 from both sides,
X equals 6.
no, I'm not done yet. 96. So she would have to get a 96 on her next test to get that A in the class. Measures of variation. Talk about the distribution. Or like the whole amount, or how far apart things are, how much it's spread out. if, you know, when we talk about measure of central tendency, a perfect bell curve has that big lump in the center, but maybe you have like a long skinny BART and a lump over here. The measures of central tendency would still tell you about where the lump is, but the measures of variation tell you about the long skinny part too. So this is a bigger picture. It tells you about the whole range of the data. Okay? And speaking of range, the range is the difference between the largest or greatest and least value. Okay, so the range tells you how far does it spread. Because you take the very, very largest number and you subtract the very, very smallest number from it, and that gives you your range. So we have Olivia is walking to school. She's taking 28, 15, 15, 12, and 14 minutes. And we're going to find the range. Well, 28 is the longest time. And 12 was the shortest. So I'm going to do 28 minus 12, which is going to give me 16. So my range is 16 minutes. Okay. Quartiles. Remind you of any words that you know really well, like maybe, I don't know, quarter? And how many quarters are in a dollar? 4.
4.
Yeah. So we've got quartiles. Separate your data. Separate rate. I spelled separate really, really, really wrong. Separate your data into 4 parts. Okay. The lower quartile divides the lower half of the data into 2 parts. And the upper quartile divides the upper half.
Into 2 halves?
Uh-huh. Yeah. So what we do is we want to find the median, the lower quartile, and the upper quartile. And the median is actually a quartile too. It's like the middle one. So if you were talking about quarters, the lower quartile would be like 25 cents. The median would be 50 cents. And then the upper quartile would be 75 cents. And then the dollar would be the very end of the data. Okay. So first we need to put these in order. Okay, so our smallest is 14, and then we have a 16, and then I have 2 17s, 20, 21, 26, 28, 29, and 35. Okay. And like I said, I always cross them out to make sure I didn't miss any. Okay, that's putting them in order. Okay, second, we're going to find that median. Now when I find the median, I start counting in from the outside. So what I'm going to do to indicate I've counted is I'm going to start just drawing little lines under it. So I've got 4 here, 4 here. So my median is actually going to be right here, isn't it? So this is my median. So to find my median, I'm going to add 20 and 21. What, 41, not 42. And then I'm going to divide that by 2, so I'm going to get 20.5. So my median is 20.5. Now I'm going to find the lower quartile. So I have this bottom half right here. Isn't this the middle number? This is my lower quartile. Because it's the middle of the bottom half. And if I ended up with like just 4 numbers here, I would do the same thing I did with median. I'd add the 2 numbers on either side of the middle together and divide by 2. And then when I find the upper half, my upper quartile, I go in the middle there. And that is the upper quartile. So essentially what you do is you divide your list in half, and then divide each half in half. Does that make sense?